Hello and welcome to today's video. We're going to talk about Pascal's Triangle. So this is another way to find binomial coefficients, and I will say that it's good to find binomial coefficients that are less than about 6, but if we get x plus y to the 100th, this is not going to work because you have to make the triangle and it would take forever. So what it really says is it says c choose n of n minus 1 choose k equals c choose n k minus 1 plus c choose n k for n is greater than or equal to k. But I don't really like to think about it in that definition. I like to think about it with this right here. So what it's saying is that you can take, once you have a triangle, so you start with this little baby triangle here, the first 3 numbers, but then it says these will always add up. So if you make a V, they're going to add up to that. So 2 choose 1 plus 2 choose 2, that's this part, is going to equal 3 choose 2. So let me show you what I mean. Let's look at the real Pascal's triangle. So if we do this out, and 0 choose 0, well that's 1, 1 choose 0 is 1, 1 choose 1 is 2, is 1, and then I have 2 choose 0, 1, 2 choose 1 is 2, so on and so forth, and it would be 1, and then it would be 3, 3, 1, just by doing these combinatorics, and it would be 1, 4, 6, 4, 1, then it's going to be 1, 5, 10, 10, 5, 1. Hopefully now you see the pattern is that I can take these two numbers, so 1 plus 1, and it's going to equal that new one, 2. Here, 1 plus 2 equals 3. 2 plus 1 equals 3. 1 plus 3 is 4. 3 plus 3 is 6. So you can use this to get the coefficients of a binomial. And so now let me show you what I mean by that. So if I have x plus y, so x plus y to the n, or to the third. Let me show you how I would do that with this equation here. So you go to the third row of the kind of expansion, but it has to start here. It starts here. So it's 1, 2, 3, 4, 5. So this tells me the coefficients that are going to be in this expansion. So it's going to be 1, it's going to be 3, it's going to be 3, and 1. So it's going to equal 1 x cubed y to the 0, and now you have to remember how we do the expansion. We start with high and then go low. So we start with x being as high as it can be, which is going to be the n, which is 3. Then we kind of count it down, so plus, and now we look at the next one in the triangle, which is a 3. So plus 3, and now it's going to be x squared y to the first plus 3 again. That's the next one in the triangle, plus 3 x to the first y squared. Lastly, plus 1 x to the 0, y to the third. And I could clean this up and just say it's x to the third plus 3x squared y to the first plus 3y squared x to the first. I should say xy squared. Looks a little bit better. So 3xy squared, and then plus 1, I'll just say y to the third. So that is the expansion, and that's how we use the Pascal's triangle to kind of help us out. So we kind of just can make this little baby triangle, and then we just go through the expansion and look for n. We look for the n plus 1 row, and then those are going to be the coefficients. So if you notice, this can be a lot quicker than the binomial theorem sometimes. If I have like n to the 5th, or if n equals 5, or if n equals 4, it's pretty quick. But if I have n equals 10, you would have to make this triangle all the way to the 11th row, really. And that would take a while. So I want you to know, just make sure that this one is not a row. This is not a row. Because that would make you 1 off every time. You'd be 1 too small. You'll also notice that the number of terms has to match up. So obviously when you expand something that has a power of 3, there's going to be 3 plus 1 or 4 terms. So that's going to correspond to the row with 4 terms, which is the third row of Pascal's triangle. And so these combinations, while they are, that's basically, this side is what I'm talking about here. That's basically just so the math makes sense, but this is what it actually is in practice. And this is what you would write down on a test or something like that. You would write down the triangle with the numbers in. So use Pascal's triangle to expand the following: x plus y to the 4th. So you might say, well, I know how to do this by the binomial theorem, and that's fine, but we want to do it by Pascal's triangle, and I'll show you why it's a little bit faster. So I'm going to start by drawing my triangle. And as soon as I can, then I start making my triangle. So it's 1, then I'm going to add up the v, which is 2, and then 1 again. 1, add up the v, 3, 3, 1. Remember, I'm adding up the 2 on either side of the above. So that's how I'm filling this triangle out. Okay, so I know that this is 2, this is 3, so I have 1 more to go, right? So now I'm going to do 1 on the outside as always. Now it's going to be 4 plus 6 plus 4 plus 1. And now I'm ready to go. This is going to be my important row. These are going to be my binomial coefficients for this example. So x plus y to the 4th equals, well, my first coefficient, this means kind of the power, it's not part of the triangle. All right, so first one, it's going to be x to the 4th plus, and now remember I start with x being as high as it goes, and each term I bring that power down by 1. So now it's going to be 4x cubed y to the 1st, because if I bring the power of x down by 1, the power of y needs to go up by 1, plus 6x squared y squared plus 4x1 y3 plus 1, and now it's going to be, I won't put a 1, there's no point, and now it's going to be x to the 0, which is just 1, y to the 4th. So that is the expansion of x plus y to the 4th. As I said, it's a lot faster than the binomial theorem sometimes. So hopefully that makes sense. Hopefully you kind of understand Pascal's triangle now. The formal definition is pretty confusing, but just know how to use it in practice and you'll be good to go. Thanks for watching, and let me know if you have any questions. Have a good one.